Hi, Divagi and Akmal.
Hai doktor, doktor saya nak ambil parcel sekejap.
Okay.
Hi, Doctor. Good evening.
Hi, Divagi. Divagi, did you take Digital Logic last semester?
No, Doctor. I buat pengecualian kredit.
Oh, but you already done with the Digital Logic, so you
Oh,
know.
I pun ada ni, pengecualian kredit.
Oh, yesterday siapa yang tanya dia tak ambil Digital Logic? So if you don't have basic
Saya
on,
dulu elektronik.
oh, because if you don't have basic in Digital Logic, you will be having a difficulty, especially for numbering system, right?
Okay, Doctor. First, I feel like a blur. Once I
The
do
one.
revision, the doctor videos all can catch up.
Okay. So need to like slowly. Uh, I think okay. Akmal already apa take partial ya tadi. Okay, I guess maybe we can start, and I also record this session so then the rest who cannot join us tonight, then he can like just watch back the video, right? So later I'm going to upload into the e-learning. Okay, the purpose of this extra class basically because there is some of you didn't take digital logic and yeah, some of you like I think forgot already about numbering system. But if you look in our module 2, we did some recap, especially for numbering system. If you remember, okay, I just go through a little bit. You can see here. Okay, if you can see here, this is the things that we did some recap, especially on the representation, unsigned and signed number. The problem is I thought that all of you already like master in numbering system because this numbering system is already done in digital logic. I think if you watch back the video, I always like repeating my word like okay, this addition, subtraction, and arithmetic representation and extra all already done in digital logic. But somehow, yeah, if you cannot understand numbering system, you cannot answer the basically for the test, right? Because all like our things like in the fixed number representation, fixed number, integer, arithmetic, we have several methods. So all of these are applying like binary numbers. So you need to know how to convert from decimal to binary, from binary to decimal. And you will always play around with those numbers. Okay, wait. I forgot to. So today, what we're going to look is very basic. So for those like already master, maybe it's quite boring. But I just want to have your friend who like still like having like amateurs, which is like very basic knowledge in numbering system. So let's go back to like very basic in numbering system. Okay, basically we have several numbering system, which is we have like base 2, base 3, base 4, 5, 8. Basically we can have 5, over here is 5, 6, 7, whatever base number we can have it. Only that um in our digital logic subject, in our COA subject, in our computing, we always look into binary, which is base 2. Why base 2 binary? Because binary representation only have 0 and 1. And our computer, our laptop, whatever machines only understand 0101. Let's say I type Lisa, which is at my keyboard. I type Lisa, and our machine, our laptop, our computer will translate this. Of course, it will translate because they didn't also understand what is Lisa here. They didn't understand. It just understand in term of after I like key in L first. So our computer will translate it using 0101 numbering methods. So in numbering system, it's going to translate using this, and we call it as machines programs or machines code. So our computer only understands 0101. That's why you need to know binary at least. Of course, in digital logic, you already look into like octal, decimal, hexadecimal. But in terms of, because we are currently look into COA, which is computer arithmetic, which is like, it is about computer. So computer, we're going to look more on binary. Someone want to join? I hope that it is auto admit. Why can admit? Sorry. So here we continue. Okay, that's this thing that I mentioned, which is most of us basically I don't know what is base 10, what is decimal. So our normal numbering system, like we mentioned, 197, 197. So this is basically base 10, or it called as decimal. But we normally didn't put this. We just like writing 197 without putting the best, because it is our day-to-day number system. So why we need to put that? So in our mind, we need to know that our numbering system is base 10 and decimal. That is the thing that we need to know. That's why if you can see here, it is base 10, and you need to know the numbering system that available in our base 10. It only have 10 digits representation. So you can see here, first digit is 0, second digit is 1, third digit is 2, until 10 digits, which is 9. So all together have tens from 0 to 9 representations in our numbering system, which is base 10, or it called as decimal. So how are you going to know about your numbering? Doctor, it is because we have 197. Why you said that it's only until 9? Because over here we have like 100. Maybe we can have also 1,000. We can also like having billions. But you mentioned it's only 0 until 9. Yes, it is 0 until 9 because the thing that you represent here only 0 until 9, which is, this is 1, which is over here. This is 7, which is digit here. This is 9, which is here. So basically that you only can represent the thing which is under range of past 10, which is 0 from 0 to 9. And altogether is 10 representations for your base 10. And how you determine the value. Okay, let's say over here, we go for base 10 first because this is your day-to-day numbering, so it is easier for you to understand. Okay, let's say I have 197. How I can measure this? If you don't know about like numbering, if like you just want to learn about numbering, you will like mentions okay, this is 197. Without your knowledge, it is 197. How you determine this is 100? So basically in numbering, we will notice here there will be a radix point. We're going to have a perpuluhan here. And after that, we're going to have like a floating point. But ignore first this. After our radix from a point to the left, you're going to start because it is base 10. You're going to start with 10 to the power of 0, 10 to the power of 1, 10 to the power of 2. And if you have another value, it's going to have 10 to the power of 3, 10 to the power of 4, until infinity, of course. On your right, how are you going to determine your value? It's going to have 10 to the power of minus 1, 10 to the power of minus 2, and etc. Okay, now we're going to look into the integer part only, okay, first. Now, how you determine the value? Okay, this is 7. You're going to multiply with 10 to the power of 0. So, whatever number that you have power of 0, you're going to get 1. You try to use your calculator, type 10 to the power of 0, you're going to get 1. So, you're going to do 7 multiply with 1. You're going to get 7. So, this is this part only. Kalau dalam bahasa Melayu, you belajar sa, puluh, ratus, ribu, and etc. Right? So, this is sa, this is puluh, this is ratus. So, you can see that it is related to each other, which is sa is 10 to the power of 0. Puluh is 10, which is 10 to the power of 1. Whatever numbers that power with 1 is going to be that number, which is 10. So it is puluh. And then ratus, which is 10 to the power of 2. 10 to the power of 2 is going to be 100, 100. So you're going to multiply with 100, which is 1 multiply with your 10 to the power of 2. Now you're going to multiply with 10 to the power of 1. So you're going to do like this. And then you have 9 multiply with 10. So all together, you're going to have 100 here plus you're going to add with our 9. 9 will be multiplied with 10. You're going to get 90. Now you have 7 multiplied with 1. You're going to get 7. That's why at the end you're going to get 197. So that is the thing. You were given with numbers, which is digit 7, but you place it, you letak dia di bahagian sa, which is di bahagian 10 to the power of 0. 9, digit 9 here, you put at the puluh, which is 10 to the power of 1. And the digit 1 here, you put at the ratus, which is 10 to the power of 2. That's why you get this thing. This is basically your basic numbering system, which is decimal. So then at the end, you can say, okay, this is 197. So for those like yang baru belajar nombor, which is like budak-budak, which is they just know this is 1, this is 7, this is 9, this is 7. So they don't know basically, okay, this is 197. They know this is 1, 9, and 7. So how you can determine and get the value basically, it is using that method. So So that method basically you already learned in digital logic subject. How you going to get the value. That is the basic thing about numbering system, which is our day-to-day number. Now go for our binary. Binary is base 2. Because it's base 2, our numbering will starting on with 0. This is 1, and because we have 2 base only, asas 2, that's why we only have 2, 1 and 2. Digit 1 we have 0, digit 2 we have 1. That's why in our base 2 we're going to have only 0, 1. We cannot have like this 3 1 0 base 2. We cannot have this number 2 1 0 1. Let's say base 2. You're going to have the small base dekat bawah hujung number awak. You're going to see this base 2 number. We cannot have this because there is 2 over here. Our base 2 is going to have only 0 1 0 1. So now if we have base 2 number, how base 2 going to get the value in terms of decimal? Because our day-to-day numbers is decimal, right? So if you have base 2, let's say I have here the very basic one, I have 1 0 base 2. So what is the value basically in our normal day-to-day numbering system, which is base 10? So you need to convert from binary to decimal. How to convert? Okay, now we have 1 0 base 2. Of course, after that, there is a radic point. We ignore this fraction part. We're going to look into this. As I already mentioned just now, our numbering system, we're going to have, if it is base 2, we're going to write 2. And then we're going to start with the power of 0. After that, we have to the power of 1. If we have another number, it's going to have to the power of 2. Next, to the power of 3 and etc. Why 2 again? I repeat, because it is a base 2. So, because it is base 2, it's going to have 2 here. And what you're going to do with the digit representing here? You don't know the value at first. You just know it is 1 0. So you can see it is at this place. Dekat tempat macam tadi we have sa, puluh, ratus, ribu and so on, right? So it is at this place, which is di bahagian, we cannot call it as sa anymore because it is base 2. It is to the power of 0. And over here, it is at to the power of 1. So what we need to do is we're going to multiply it, and this answer we're going to add. 1 multiply with to the power of 1. To the power of 1, you can just using your calculator and with your logic, every numbers that have power 1, we're going to have that number, which is 1 multiply with 2. And here, 0 multiply with any number, of course, you're going to get 0. But what is to the power of 0? Whatever number with the power of 0, you're going to get 1. So over here, 0 multiply with 1. Then you add this total. Add this total, we're going to get 2 plus 0. Then you can conclude 1 0. You cannot say 10, okay? It is not 10 because it is base 2. This is 1 0. 1 0 base 2 is similar with the value of 2 for our normal numbering, which is base decimal or best 10. Okay, let's say I give you another example. We go much higher number. Let's say I have 101. Best 2. You cannot have like 2, okay? Because I already mentioned we only have 0 and 1 as the numbering representations for binary. So if here, what we're going to do, we're going to put 0 to the power, to the power of 0, to the power of 1, and to the power of 2. So then we have over here like this. We have to separate it because we want to know which one is going to multiply which one. So over here we have 1 multiply with 2 the power of 2. Okay, use your calculator to the power of 2. What are you going to get? And plus with 0 multiply with 2 the power of 1. To the power of 1, what are you going to get? And then you're going to add 1 multiply with 2 the power of 0. So this is a method for you to convert binary to decimal. Okay, now you have here, you're going to solve, it's going to be 2 times 4. To the power of 2, you're going to get 4. And then you're going to add with 2 multiply with 0 multiply with 2 the power of 1. 2 the power of 1 is going to be 2, but numbers here is going to be 0 multiply with 2, going to get also 0. And then plus with, sorry, there is a factorize over here, okay? And 1 multiply with 1. 2 power of 0, you're going to get 1. And you can solve it. This will be 4, this will be 0, this will be 1. 4 plus 0 plus 1, you will get 5. 5 what? 5 best 10. So this is a 5 best 10. Just now you have 1 0. 1 0 equal to 2 best 10. Now you have 101. Best 2, you're going to get 5. So that is the thing. So you need to like try to play around with those numbering, and you're going to get familiar, which is like to the power of 0 is what, to the power of 1 is what, to the power of 2 is what, to the power of 3. Maybe you can go up to like to the power of 5. Sometimes that is maximum. I think 6 is better, which is like to the power of 4, which could be 16, and then after that 32, and then 64, and another one is 132. I forgot already, or 128. So you can always play around with your calculator later on, but if you like already like memorize it, it's going to be faster, right? So that is on binary. Is there any question on binary to decimal? Now, can you understand that binary terms and convert it to decimal?
Can, doctor.
Okay, thank you, David, Diwagi, to respond. Okay, now let me try to share that another one more things. I think it is not covered in COA, but you can have also several other best number, which is best 8, best 16. Okay, this is frequent use in your digital logic subject. For best 8, or we call it octal. Remember, if 8 is going to have 8 in total, which is started with 0, and that's why your maximum numerals number system representation until up 7 only. So you're going to have like this 6, 5 maybe, and then base 8. So it can be possible to have this number. But you cannot have like 9, 1, base 8. You cannot have more than 7. It is not possible to have that. So if let's say you have base 8, how you going to get the value if you want to convert it to your normal day-to-day activities numbering system? So you're going to convert it using the similar method. So what is the similar method? You're going to do like this, which is where I give you example, a very simple one, which is 1 and 2. This is not 12, but this is 1, 2, base 8. Okay, if you want to represent it to your daily numbering system, which is base 10, you do the similar things, which is, remember, this is base 8. What you're going to do, you put base 8, which is 8 to the power of 0, 8 to the power of 1. So next, what you're going to do, you're going to multiply. Here, going to do multiply. You're going to do multiply. And both answer, you're going to add. So 1 multiply with 8. Why 8? Because 8 to the power of 1, you're going to get 8. 2 multiply with 1. Why 1? Because 8 to the power of 0, you're going to get 1. And you will get the total of 8 plus 2. It's going to be 10, base 10. So 10 in your normal day-to-day activities. Let's say I said, okay, I have 10 apples. Can I represent that 10 apple in octal? So I'm going to have 1, 2, base 8. So it is a similar value. You can apply, if let's say that is not listed here, I have 2, 1, base 7. So how I'm going to get the value in terms of my normal day-to-day numbering, which is base 10? It's going to have 7 a power of 0, and then 7 to the power of 1. So you're going to do a multiplication, and then you're going to multiply here also. Then you add this value. So 2 multiply with 7. Why 7? 7 to the power of 1. You're going to get 7, and you will get the value of 14. Over here, you're going to multiply 1 multiply with 7 to the power of 0. You're going to get 1. Why 1? Because 1 multiply with 1. That's why your number will be 15. Then you can call 15 because it is past 10. If you have like 1, 5, base 7, it is not 15. There is another value. So over here, if past 10, you can call 15. This is 2, 1, base 7. You convert to decimal, you're going to get 15. That is how you're going to convert from any base. We call it from any base to decimal. We're going to do that method. Multiply and adding, multiply and adding, following the plus. Sama ada is it is like 10, or to the power of 0, to the power of 1, or maybe 3, trinary, 3 the power of 0, 3 the power of 1. So you need to know the plus, and you multiply it, and the answer you're going to add. So you know already how to convert. So this is the things which is positioning number system, your method, which is I showed you just now. what you're going to do, starting from your ready point here to the right, you're going to, if you, let's say you have this number, which is number C0, you're going to do multiply with your best number. You can see over here, best. If let's say it's best 2, you're going to multiply with best 2 to the power of 0. Best 2 to the power of 1, best 2 to the power of 3, and you're going to add all the value, and it's depend on the value also representations, and that is in integer, but it also apply for your fraction number, but it's going to start with -1, -2, -3. It is basically similar. You're going to multiply, adding, multiply, adding. So the value, let's say like 2 the power of -1, you can just use your calculator. But it is good also for you to remember, because if you have the numbers, then later on you're going to multiply it, you can direct multiply. Okay, this is the example. Just now I already shows it. Why you call it 4,839.72. So you know already, it is like 10,000,000. But in terms of someone who didn't know about number, they will like say 4,839.72. They don't know basically what is the value in magnitude. They just know, okay, this is the number. But how you determine the value, it is by using the things that I shows you. If it is at like 10 to the power of 3 place, which is ribu, you're going to multiply it. This is the way you're going to do. And then you're going to add with 8 multiply with ratus, which is 10 to the power of 2. And then you're going to add with 3 multiply with 10 to the power of 1, which is puluh. And you're going to do another one is 9 multiply with 10 to the power of 0, which is sa. Then you have the ready point here. You can also do the similar thing, which is over here. You're going to have 10 to the power of 10 pula. 10 to the power of -1, and 10 to the power of -2. And if you have more, it's going to have similar, and etc. You can see you're going to multiply 7 multiply with 10 to the power of -1, 2 multiply with 10 to the power of -2. So please make sure also you know how to use your scientific calculator, because if you want to know the value, you're going to play around with that, right? Okay, that is the things on representations. You will have integer part. You will also have the fraction part. This one we also already learned in our COA, which is to the recap just last time. And you're going to have the numbers of MSB, which is most significant bits, and you have the less significant bits, LSB. But I don't think this is used for your COA. The things that let's we go directly for our binary. Okay, this is our binary numbers. This is what is the value for to the power of 0, to the power of 1, to the power of 2, and etc. Representations for the wasted dekat sa, puluh, ratus, ribu, and etc. So what is the value? To the power of 0 is going to be 1. To the power of 1 is going to be 2. To the power of 2 it is 4. To the power of 3 it is 8. To the power of 16. And to the power of -1 it is 0.5. To the power of -2 it is 0.25. So all the value you're going to multiply. Let's say you have this example. You have 10011.01. So what you're going to do, you're going to multiply at the specific place. Over here, you're going to multiply with to the power of 0. This one to the power of 1, to the power of 2, to the power of 3, and to the power of 4. You can see here 1 multiply with to the power of 4. Add with 0 multiply with this part. Okay. 0 multiply with to the power of 3. Here 0 multiply with to the power of 2, and then 1 multiply with to the power of 1, and another one is 1 multiply with to the power of 0. After that, you have the fraction number 0 multiply with to the power of minus 1, and lastly 1 multiply with to the power of minus 2. So when you uh, get the value, you can add all together, and then there is no value at the end. You can try to calculate and get the value 16, 18, 19.25 in decimal. So maybe you can play around with several like number. You change the digits, numbers, and try to get the value. And if you go for, I I think in your calculator also you have, which is a convert. You can directly convert binary to decimal, decimal to binary using your calculator. Okay, there is a several example here. How you going to get the binary to decimal. Okay, next. You can see here, this one is octal. Just now I already mentioned, this one is covered in digital logic. But yes, I think it is not going to be octal. In COA, sometime you're going to look into hexadecimal. Oh, I think that is also important, but it is not in your test one. I guess later on in your uh, assembly language, you also might have to use the hexadecimal numbering. Okay, for octal here, it is also basically similar if you want to convert base 8 to decimal. Any base going to decimal, you will use the similar method. This one that is,
Doctor,
yes,
quick check. For our test this weekend, this will come out, is it?
octal no. I
No, I
think
mean this concept of binary numbers,
yes,
these
binary number.
calculations.
Because if you look into your slide, module 2 under COA, you're
Okay.
going, okay, you're going to play around with this all numbering.
Okay. I think I haven't reached that part yet in the part two.
Huh? I
Yeah.
think it is in the early stage, and we
Okay.
also have touched it in the class. I think better for you to check back.
Okay.
Okay, because we also going to have this thing. If you still remember, we're going to have
Yeah, yeah, yeah. Okay, okay, okay. Sorry, it's okay.
okay.
Understood. Terlupa. Okay.
Okay.
Okay, okay, okay.
So it's going to be covered until the end of your module 2.
Okay, okay, okay. Yeah, I remember now.
Okay.
Okay.
Now you can see, where is my digital logic? Okay.
Thank you, Doctor.
Okay. Now you can see here, there is example, it's basically similar. Just now, okay, over here. So the value is error, this thing, but you can see it is using a similar method. So you can, this one is basically for your understanding. You can basically go for your test one by using your calculator, which is convert. But it's better for you to understand, because sometimes it is very simple for your multiplication, something like that. You just give like maybe 9 multiply with 5. So it's going to give you like best 10. So please use the method of hardware, what the method name, which is you're going to convert this to binary. So you can like directly use your calculator, but it is good for you to know, okay, what is 5 in binary? What is 9 in binary? So we're going to reach that part, how to convert decimal to binary. Just now we learned any best to a decimal. After this, we're going to learn like binary to decimal to binary, decimal to octal, decimal to hexadecimal. So all of that, there is a several method. Okay, this one is octal numbering system, and here we are, hexadecimal. Hexadecimal is base 16. So base 16, of course, we're going to have 16 digit representation on numerals. You can see here, we're going to start normally at 0. But in our numbering system, the maximum number will be 9. So if let's say we can have like, of course we have 10. But if 10, we already uh, we're going to occupy two place. We're going to use a two place. We don't want that. We want only one place, because it might be confused if you have 10 in the representation as 10, and after that you said, okay, this is 10 for sa, maybe, yeah, okay, we assume it as sa, and then pulo, there is another one which is 11. So it is not like this convenient, because if you have a number like 1110, how are you going to know that this 0 for that sa and this 11 for that pulo? So that's why we're going to represent one place only, one unique uh, digit number. So that's why for 10 until 15. Why 10 until 15? Because we already have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After that is continue with 10 until 15, because the best is 16. All together will be 16 digit. So over here, 10 will be represented as A, 11 will be represented as B, 12 will represent as C, 13D, 14E, and lastly F is equal to 15. So you need to like get to know on this hexadecimal also, because in your coding assembly language, sometimes they use like this one, move uh, E A X uh, 7 H. So H represent hexadecimal. So it's 7. So you know it is a value of 7. If like A, you need to know it is 10 hexadecimal. So this thing you're going to also apply in terms of assembly language, but it is not yet covered in your test 1. But it will also apply in your COA subject. Okay, so that's why you need to know hexadecimal numbering. And all of this you already learned in digitalogy subject. So you're going to see 16 possible symbol, 0 until 9 and A until F. And it is represented as 10, 11, 12, 13, 14, 15 in decimal. Then how you going to convert also from hexadecimal to uh, from hexadecimal to decimal. Okay, let's say you ada number, and I pick only easy because it's going to be easy for me to multiply it. If I have 1 3 hexadecimal or base 16, or maybe I can also represent like this, 1 3 H. Then I know this is hexadecimal because in your assembly language you're going to apply like this. You're not going to have, in terms of typing in your coding, right? You cannot have like 13 16 best. No, in your coding there is no like casting. That's why in your coding, in your upcoming your assembly language, you're going to have like 1 3 H. It is called as also 1 3 hexadecimal or base 16. So because this is base 16, how you going to convert it to decimal or base 10? So you're going to apply similar thing. You're going to have 16 to the power of 0, 16 to the power of 1. Then you're going to multiply. You're going to multiply and add the value. 1 multiply with 16. Why 16? 16 to the power of 1, you're going to get 16. And then you plus with 3 multiply with 1. Why 1? Because 16 to the power of 0, you're going to get 1. And that's why you get 13. It will be 19 in your decimal. So any question for this hexadecimal numbering?
Clear, Doctor.
Okay, thank you. Okay, now let's proceed. What else? Okay, just now, you know that you're going to convert from any base to decimal. So the thing is very easy. So now let's move to a decimal to any number. Wait, oh, this one. There is several method, but I don't want you to focus on like let we focus on binary and decimal only for cover in our test one. Okay, where is binary to decimal to any number? One is octal. Okay, now if you want to convert from decimal to binary, from decimal to binary, how you going to convert? Because if you check your COA subject, which is in our module 2, we will given you we will give you only decimal number, and then you're going to apply into several method. Before you can apply into several method, you need to know the value in binary. If you check back, it's going to play around with binary. So how you want to convert to binary? So here is the method, which is using successive division. You're going to repeat division, going to repeat divide with your best number. If you have best 8, you're going to divide with your 8. If you have 2, you're going to divide with 2. If you have best, you want to convert from decimal to base 3, you're going to divide with 3. If you have 10, you want base 10, you want to divide with you want to convert to base 7, you're going to divide with 7. So you akan bahagi, repeat bahagi tu with the following base number yang you nak convert. Okay, let's say we have the value 42. So this is 42 in decimal. You're going to divide with 2. You akan bahagi dengan 2. So how you going to get? You're going to have 42 divide with 2. You're going to get 2. And then another one is 2 and then 1, and you have 2 here, and without any baki. There is no any because you're going to get only digit integer number. So from here you're going to get 2 1, and then there is no anything which is you're going to put 0. there is there is no reminder here. You're going to put 0. You can see, because there is no baki or reminder, going to put as a 0. You have an here, it is 2 1, which is 21. What you're going to do, you're going to divide again, because repetition division. Okay, you're going to do repetition. So you're going to do 21. You divide with 2. What you will get, you will have over here is 1, 2, and then there is no reminder. You're going to bring this down 1. This will be 0. 0, right? Then you will have reminder of 1. Don't do until what fraction number. Tak perlu nak letak point-point. Dalam normal mathematic, you're going to have like this point and extra to put over here as a 0, right? But in the conversion here, no need for you. So if you have like 1, you're going to put 10, and then it will be having a reminder as a 1. So you will get 10 as the answer here, and with the reminder of 1. So this is your reminder. And you can see 10 still can divide with 2. 10 still can divide with 2. What is your answer? You will get 5. Without reminder, it will be 0. And then 5 still can divide with 2. Then you divide and you're going to get 2. And with reminder of 1. 5 divide with 2, you will get 2 here. And because of 2, you bring this 2 to here, and you will get 4 with the reminder of 1. So you put here 1. Just now you have 21. You put here with no reminder, you put here. This one, you have 1 0, 1 0 here, you put here, which is 10, with the reminder of 1. Now you have 5 divided with 2. You get 2 here, and the remainder is 1. 2. Is it can divide with 2? Yes, you still can divide 2. Divide 2, you will get 1 with no reminder. 2, divide with 2, you will get 1 with 0 reminder, or 0 baki. Then that is your answer. How to get your answer? 42 decimal. What is your answer in binary? Best 2, because you divide with 2, so it's best 2. You're going to look into like this. From bottom to upper, your answer will be 1 0 1 0 1 0. Best 2. So this is your answer. You can easily convert it using your calculator and check, is it you going to get a similar answer or not. So that is the answer. So if you want to prove, let us prove is it correct or not. So this will be to the power of 0, to the power of 1, to the power of 2, to the power of 3 to the power of 4 to the power of 5. If you check to the power of 5, you're going to get 32. And then you're going to multiply, right? 1 multiply with 32, you're going to get 32. And then 0 multiply with 2 the power of 4, you're going to get 0. So I know, okay, here. 1 multiply with 2 the power of 3. 2 the power of 3, you're going to get 8. So 1 multiply with 8, you're going to get 8. 0, 1, 2, 3, 4, 5. Okay. Then you have another one is what here? 0. 0 multiply with 2 the power of 2, you're going to get 2. Here, you're going to get 0. 1 multiply with 2 the power of 1. To the power of 1 is 2. So that's why you will get all together total. If you add, you're going to get 42. So your answer is correct for your binary here. So this is the numbering. You can see from 1 until 15 in decimal, in our normal number. And then it is in binary. This one is in octal. This one is a hexadecimal. So this one is decimal to convert to hexadecimal. For this part, you can see over here, we're going to do repetition division also, which is with divide with 16. And then you're going to put the reminder, if you have the reminder here. But it is slightly different because if the reminder is 2 digits, if it is 10 or 11 or until 15, we're going to change it to the representation. 15 will be F. Then you check back 1 to 7, divide with 16, you're going to get 7. And there is another reminder, which is 15. So you have 7FF as the answer. So please try to do using your calculator because it's going to be directly get the answer. Check whether you get the answer or not. So play with the value. Maybe you change is 1047 for decimal. What is your answer? You do the repetitions are division and check your answer. Is it correct or not? That is the things on numbering system. I think it's already covered for the things that you're going to know on. Oh, that is a fraction number. Okay, wait. Okay, for fraction number, because you're going to also play around fraction number in your COA, you're going to see if you have this number, it is slightly different. Just now, when you want to convert from decimal to binary, what you're going to do? Repetition, division. But that is for your integer number, nombor bulat sahaja. But when you have nombor perpuluhan or your fraction, you're going to do repetition, multiplication. After this, I'm going to share this slide into your e-learning. So then you can also have and read all the what names of the method. You can see repetition, multiplication, and just now repetition, division. So what is the method that you need to apply? So I'm going to share this digital logic notes. Then you can try to do a recap. So when you have a fraction number, you cannot do division, but instead you're going to do multiplication. You're going to multiply with the base number. If you want to convert to base 8, you're going to multiply with 8. If you want to convert to 16 base hexadecimal, you're going to multiply with 16. So you're going to repeat until you reach 0. Okay, how are you going to do the repetition? Okay, if this number you're going to multiply with 2, which is 0.3125, you're going to multiply with 2 because you want to change to the binary number. Then after that, you're going to get the answer like this. You need to bring only the fraction number to do the repetition, because there is also student like getting this answer, then they say, doctor, when I multiply, I will get like 3 over here or etc., because you bring this together, which is digit number. You cannot bring the digit number. What you're going to repeat only the fraction value. So you're going to repeat the fraction value only. So you will bring down the 0.625, and then you multiply with 2. You multiply with 2, you're going to get 1.25. Then you will repeat again, and you only bring this 0.25. You're going to bring only 0.25. And you repeat until you get 0, which is, although it is 10, if you bring 1 in front, you're going to do like repeat. But the thing that we only bring is 0, fraction number, right? That's why you will repeat 0.0 multiply with 2. You didn't going to get anything, which is you're going to get 0. Then you repeat again, you're going to get 0. So that's why after you reach like 1.0 or 0.0, you're going to stop. But somehow, sometimes you have unlimited repetition, because sometimes the value is like 1, 2, 3, there is a lot of number, and then when you repeat again, you cannot get until 0. So when you're going to stop, it is referring to the question. Normally we're going to have only 4 repetition times. So the question will say until 4 fraction number only, sehingga 4 nombor perpuluhan sahaja. That's why you're going to stop. Although you can repeat again, but you just stop and take the answer until 4 fraction number or 4 nombor perpuluhan sahaja. Okay? So that is on fraction number. This thing you will apply also in your COA subject. So go back to your COA slide. Okay, we will use all binary and decimal number. That's why I teach you binary and decimal. This is all the recap we already done. And still there is first complement, second complement, especially for arithmetic. That one also we will cover because it's already covered in your digital logic subject. That's why the digital logic is like supposedly compulsory for those who want to take the COA subject. So you can see over here, sometimes you will be given only like decimal value. So you're going to say, okay, please use the sign, magnitude, arithmetic in add with binary. You can see binary number. So can be easily convert using your calculator. But you need to know also what is this 1010? So you now you know already it is supposedly to the power of 0, to the power of 1, and etc. That's why you get the similar value of this. So in the recap things, we did cover the unsigned number, the signed number, and let me think for a while whether the two complements are covered or not. Basically, for your module 2, the most important is at this part, which is on the method. Okay, this one. Where is it? Okay. Last time in our class, I already asked you to try to play around with this because it is covered in your past year test 1. There will be like a mass question, especially for part B. I already mentioned that it is mostly going to cover in your part B. So you need to understand the flow. Last time in our class, I asked you to do example number what? This example, I think 2.2, and I asked you to do. Instead, I already also uploaded the video on how to solve this solution 2.2. And the thing is, you can see how the question give. You can see over here, it just give you the value. You need to know which is product, which is multiplicand, which is multiplier. MP, MC, MP. So in your part 2 or part B, they will give you a table like this. They will also mentions to you that this is MP, this is MC, and this is P. And it will state it over here also how you're going to write the value inside the table. And it will be close to each other. But it's okay. You can refer back to the instruction. It will mention that without space. So if you type, let's say you type 0, 0 with a space here, 0, 0, your answer is correct. Let's say the correct answer is like this, 0, 0, 1, 1. But you by mistake, you put space and then there is 0, 1, 1. You will get wrong for this part. Although this you said, Doctor, it is correct, right? Because it is 0, 0, 1, 1. But with space here, you get wrong because it is what we call the question. It is marking by e-learning. So e-learning as a computer, they don't know this thing. They just like say, okay, you put it incorrect. That's why we put the instruction at this side. At each of the table, we will put like the answer should be without space. And we will give you the example like e.g. 0, 0, 0, 0, and etc. Which is we will give you example how you're going to write your answer here. Similar to your MC, similar to your product, there is no space. So please make sure you write it carefully. And we will give you basically similar table. You just need to fill in the value. So please make sure you try and go back to look and watch my video that I already.
Doctor,
Yes,
Doctor, for just now, Doctor mentioned no space, right? For
yes,
multiplier.
yeah.
Like a multiplicand, right? We have 8 bit. That means the 4 bit, after 4 bit, we must have a space or no need?
No,
No space.
yeah.
Okay. Okay,
No
okay.
space. All, I think all, including others question also without no space.
Oh, okay,
But
doctor.
to make sure you can read carefully the instruction, okay?
Okay,
We will
doctor.
give you an instruction. So all the thing you can see here, you were given only this question which is in decimal. You can use your calculator, of course, but there will be information without calculator. You need to know how to convert and which one is MC, which one is MP. So over here, when you put and then you're going to put all the value inside, you need to know, okay, this is 3 in decimal and binary is going to be 0011. And the format of this, you can see multiplier is going to be like only like 4 digit. It's depend on the questions. And you can see over here, where is it? Okay, you need to know the digit for the first multiplier value, which is this part. If this is 1, then you're going to go for 1A. If this part is 0, you're going to go for this. So please check back our videos, our notes in the e-learning. So maybe you can try also this example. And there is several other things which is you need to know the rules. You can see over here, if you were given with negative number. Just now the example is positive. You can see here. If it is negative, how you going to do? So if it is negative, you can doing this thing, which is you already learned basically in your digitalogy subject also. But you can see in the number 7 multiply with negative 5. So it's going to be a negative 7 multiply with 5. So you just change the value because negative, because you will notice how to convert to negative number. You're going to do with the second complement. That's why you need to play around with the negative value and etc. And you will be also, you can see over here, this is sample for negative value. And this value is not 2 because I mean it is not 2 which is 0000010. For 2 it's going to be 10, right? But this one is the value in second complement. Check back the second complement, how you going to get negative 2. Negative is representing how second complement, how we're going to represent it. Okay, now over here, you will also have a multiplier. Okay, you're going to have the division. Okay, you have two part, divisions and multiplication. So both have this table. You can see over here, table for divisions. You need to know either one because sometimes you were given with this multiplier, sometimes you are given with division, but these two is must. You will be asked in your part B. We will shuffle. It is we not going to pick like your name we're going to get division, your name we're going to get multiplier. No, it will be shuffled by e-learning. So it's depend on you. Maybe you're going to get multiplier, maybe you're going to get division. That's why you need to know both. Okay, so please try to do it and get familiar with the table. And we try to help you in this thing, I think so. If you check your multiplier, you're going to have also this step. At this step, it is just the scroll down. You can just click over there, and there is a several answer. You just pick the correct step. So the correct step is very easy, because if you know the value, if you know the, I think we provide you with this flowchart at the question. Yeah, I can't remember, but my question I put this because there is two lecturer are doing this question for your test one, upcoming test two, upcoming final exam also. We two lecturer we combine, which is one lecturer from Perdana, which is from UTM Perdana section, and me from space. We combine the question together. So my question, I think I put the flowchart. So maybe the lecturer also similar.
Doktor, kalau doktor bagi soalan senang-senang sikit ya.
Soalan dah dibuat lama.
Alah.
So tak boleh nak diperbetulkan. But yeah, in Saturday class, we like maybe do,
Mock tu. Go through
yeah,
mock.
mock together, and then we try to do exercise together. Maybe I'm going to play around with a past year question. Okay.
Okay.
Mm. So I think as long as you try, because normally we will just pick a question from our module, the things that you learn in
Okay,
class.
okay.
So please try to do all the exercise. We sometimes like play around with the value only, change the value as long as you know the step. We want to know your skill. Do you know what you learn in class or not? Because this is the method. If you know the method, then we assume that, oh, okay, you know and understand what you learn, and how you're going to apply it in later on in your like work and etc. So what else in numbering system? Okay, this is division. Then there is also, because all of this will be covered in your part B mostly. Part A, it is mostly in your chapter one, which is what is the theory, what is the correct term for supercomputer. What is supercomputer? So you need to find the correct answer and etc. So it is all on theory, but in terms of calculation, is going to be asked in your part B. So there is also like fraction number. Uh, this one, yes. The bias thing. I think there is a few question that cover on all after this, which is if you go for this slide, wait, okay. After your fixed number, floating point to summary, floating point representation, floating point arithmetic, all of these, especially as triple E floating point, normalized, unnormalized, uh, I think there is like two question or three question at part B, but the marks is like 5 mark only if compared to the things division and multiplication. Division multiplication, I think more than 10 marks. But for floating point, arithmetic, floating point representation, the question will be smaller part, which is 5 mark, 5 mark, and only several things that will be asked. But you need to know the method. It will be easier for you to like having a question and you submit. Okay, because I was worried. Do you prefer it will be like burden me, but I was afraid Uh, because in the e-learning, if you write it wrongly, because like this, right? Okay, you have several space that you need to fill in. If you wrongly put the answer, you will get totally zero. But if in term of submission, uh, yeah, the one that marking is me. I can see the flow, right? So I can help you with the mark. So let me see. uh,
Yay.
because normally COA subject will be marked by, yeah, e-learning, because you just key in the value, and me we as a lecturer will like just get the marks by marking by e-learning. So if possible, I can change the question. I will give only the question, then you write your answer in your piece of paper, and then you upload to the e-learning. Do you prefer that things?
Can, doctor?
So I will try to think, because if compared to the Perdana, they need to answer in the e-learning. So all the marks, all the answer will be marked by e-learning. So it's very tough, I think so. But I will think that maybe might be I'm going to change the type of question. If you want that things, I will change how the question look like. Then maybe you're going to submit your answer script to the e-learning.
Okay,
Okay.
doctor.
So in Saturday, I'm going to finalize whether
Okay, doctor.
we will do that things, or we proceed with the similar thing with Perdana, because I need to also ask Perdana lecturer, is it okay or not if I change that type. Okay.
Okay.
So that is the things on.
Thank you, doctor.
Okay, I think, yeah. The rest we will try to discuss in our Saturday class also.
Okay.
But please compile your question. If you maybe you want to know more in numbering system, please ask me any question. So you compile standby dengan question, and then in class we will like discuss together. Okay.
Okay, doctor.
So any question from your module one or module two, and then from numbering system. So after this, I will push this module two, which is numbering system digital logic, to your e-learning, and as well as the video recording. Okay.
Okay, doctor.
So any other question?
Uh,
Doctor,
Yeah.
doctor, can you please share the answers for the exercises in module 2?
Answer the things. Okay, okay. I will share the slide. I think so. Answer, then give me some time for the answer, because the slide I need to like screenshot the answer, right? So
Yeah.
I will play the slide, and then I screenshot, I play slide and screenshot, and then I will put in the e-learning. Okay.
Okay, doctor. Thank you.
doctor, I have one request. Actually, the video that doctor posts, if can you, because sometimes when I hear the video, the voice is little bit to the slower side, even though I
Oh, sure.
increase my volume. So just a kind request, if when doctor make another video,
Hmm.
um, maybe the
Okay.
voice can be a bit more louder, would be really appreciated.
Okay. Then I need to use my converter to increase the value, the voice sounds.
Okay.
Okay.
Yeah.
Yeah, doctor. Most of the videos, the sound is like very low.
Oh.
Yeah.
Betul Doctor. Saya habis guna sound speaker dah.
Guna earphone eh?
Oh, saya guna speaker ni pun saya guna.
But now you can hear me sit loud, right?
Now it's fine. The
Hmm.
video only, the recording.
Okay, okay. I will look into that. Thank you for your suggestion,
Thank
Ravi.
you, doctor.
Okay. Any other question?
Yeah, I think fine for me, doctor. Maybe on this Saturday I will be more detailed, so
Yeah,
I will wait
Yeah,
on Saturday.
me too.
prepare with the question, okay?
Okay, doctor.
Doctor,
Okay.
thank you.
Good
Thank
night.
you.
Thank
Good
you for
night.
your
Have a nice
time.
day.
Thank you, doctor, for your time.
Okay. Bye bye.
Bye bye.
Thank you, doctor. Good
Okay.
night.
Good night too.